Alright, in this video I'm going to briefly explain the steps to go from beginning to kind of end in your date of birth project, just as a quick refresher. Now we know the first step of the date of birth project is to generate the truth table, which is what you see before you here. I've chosen to do mine in Excel. You can do yours on paper, you can do yours in Google Sheets, doesn't matter. What does matter is the order that you create this truth table. We know that in the truth table we have some combination of inputs and typically one output. However, for the date of birth circuit, we have 7 different outputs. They are each of the 7 segments of the 7-segment display. We have 3 inputs, 3 switches to control each of these different digits of your date of birth. Each different switch combination, such as 000 or 011, relates to a different digit in your date of birth. Your goal is to first make this portion of the table. Make your inputs going from 0 to 7 in binary, and then figure out which digits go next to these switch combinations. So at 0, at 1, at 2, 3, 4, 5, 6, and my 7th combination, I can see that I have my different digits occurring. For instance, if my third combination of switch, or technically my 4th, I'm displaying the number 2. So at 000, I'm displaying a 0, 001, I'm displaying a 2, 010, a dash, so on and so forth. So once you've figured out this portion, and yours should look exactly like mine except for your date of birth will obviously be a little different, then you move into making the segment section. Now I'm going to go to a new sheet here, and in this sheet I'm going to pick a random date of birth. Now you'll notice one thing. On this row, on row 7, and on row 10, I already have those rows filled in. And the reason for that is because those are my dashes. Remember, our date of birth format is 02-27-96. That would be my date of birth. Obviously, Excel does some auto formatting here, so that's kind of unfortunate, but you get the point. Let's say my date of birth was October, let's do 23rd. Oops, 23rd. Let's do 2004. So October is the 10th month, the 23rd, and I only use the last 2 digits for the year 04. So my digits in ascending order are going to be 1, 0, dash, 2, 3, dash, 0, 4. Those are my digits from my date of birth. That is the order I want them to light up in using these different combinations of switches. So now I have to think to myself, to make the number 1 on a 7-segment display, what digits or what segments do I have to light up? Well, if I remember what a 7-segment display looks like, this is pretty easy. But if I don't, all I have to do is look for 7-segment display. And here's a good reference image. To make the number 1, I have to light up B and C. These are common cathode 7 segments, so I provide B and C power, and the rest I do not provide power. So this entire row right here, this entire row here, row 5 in my worksheet, is just to make the switch combination 000 light up the number 1, and it does so by turning on segments B and C. Now I'm going to look at how do I make the number 0. Well, that's A, B, C, D, E, F, and not G. So I'm going to say it's A, B, C, D, E, F, and not G. Okay, I don't have to worry about the dash because it stays the same. I'm going to make the number 2. That is A, B, G, E, D. A, B, G, E, D. And then put in a 0 for the rest of them. To make the number 3, it would be A, B, G, C, D. So A, B, G, C, D. Again, don't worry about this dash because it should be the same for you. The number 0 again is 1, 1, 1, 1, 1, 1, 1, 0. And the number 4 is F, B, G, C. So B, C, F, G. Zeros for the rest of those spots. Now, I have my completed truth table. I have 7 unique outputs. That means 7 unique circuits. The A segment circuit will have the following truth table. So if I were to take everything in these 3 columns and copy and paste it down below, let me actually modify my spreadsheet here a little bit to make this look better. If I take this and I copy and paste it, and I take this as my output and I also copy and paste it, now this looks like a normal truth table that we have seen before. I have my 3 inputs, X, Y, and Z, and I've got my 1 output, A. Now I need to make my K-map. Well, I know my K-map is going to be a 2x4, and it's going to look similar to what you see here, where I've got not X, not Y, not Z, not X, not Y, Z, not X, Y, not Z, not X, Y, Z, and so on and so forth. Using this table format, and I'm just going to copy and paste this over, I can fill in, and I'm going to delete these groupings here because this was from my old date of birth. I can fill in this K-map. So at not X, not Y, not Z, or at 0, 0, 0, my output's a 0, so I'm going to put a 0 there. At 0, 0, 1, it's a 1. At 0, 1, 0, 0. 0, 1, 1, 1. Now pay attention here, this is 1, 1, 0. Remember, you got to pay attention to what the K-map is showing you. It is X, Y, and not Z. That is this one right here. That is a 1. At 1, 1, 1, which is this cell right here, at 1, 1, 1, X, Y, Z, it is a 0. At 1, 0, 0, it is a 1. And lastly, at 1, 0, 1, it is a 0. Now, knowing my knowledge of K-maps, knowing how I make groups, I can see that there is a group here, which I'm going to fill with this orange color, and there's a group here, which I'm going to fill with this tan-ish kind of color. This group here simplifies to not X, Z. I look at what stays the same. My Y doesn't stay the same, my X does, and my Z stays the same. So I have not X, which I'm going to denote like this because it's a little easier to type. Oops, let me go back up there. Not X and Z. Or these two, X and not Z. So I have X and not Z. This is my one circuit for my A segment. So I make this using inverters, using AND gates, and using OR gates. I make not X and Z, or X and not Z, and I connect that to the A segment on my 7-segment display. Let's look for the common cathode chip for a 7-segment display. So I make that logic and I connect it right here to my A segment. This is how 7-segment displays work. Now I'm also going to look up here at this table and see if there's anywhere where the same exact vertical column occurs more than once. And I see that right here. I see that my A segment and my D segment share the same exact output. 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0. So instead of doing all of this work again for my D segment, I'm going to say my A and D segments are this circuit right here. So my A and my D segments are this circuit. So I build it once, connect it to A, and then I also connect it to D. Very straightforward, very simple process. That also applies for B and C. You'll notice that they are the exact same here as well. So I make B, and then I don't make it again for C. I just make B and connect it to C as well. So that is what you see going on in here. In this section of this Excel document, which you do have access to, I have laid out my A segment, my B segment, my C, D, E, F, and G segments. And I've made some comments about segment C and F being the same, segment A and B being the same, segment D and E being the same, because that is how my specific truth table worked out. Yours will not exactly match mine necessarily. If it does, great. You have the same birth date as me, but it probably won't. Additionally, once you have your truth table, you need 7 K-maps. You'll notice that in this document, I have a K-map here for A. I have a K-map here for B. Here for C, so on and so forth. I have 7 segments because I have 7 unique outputs. Therefore, I have 7 circuits I must build. That is what you see here on these 2 pages. My A and B segment, my C and F segment, my D and E segment, and my G segment. I'm going to scroll a bit past this to my simulation. In my multi-simulation, I've made a template where I've got switch 1 and not switch 1, or in this case, what did I use? I think X, Y, and Z. Yeah. This is X and not X, or it's X and not, I'm sorry, Y and not Y, or Z and not Z. So the blue lines are my X's, the green lines are my Y's, and the brown lines are my Z's. This first section right here that I'm circling with my mouse is my A and my B segment's logic. If I look back at this, my A segment logic is not X and not Y, or not X and Z, or X and not Z. So I've built that here. I have not X and not Y on this first AND gate. I have not X and Z on this second AND gate, and I have X and not Z on this third AND gate, and then I just use 2 cascading OR gates to make that statement. So I have not X and not Y, or not X and Z, or X and not Z. And you'll notice, here's my 7-segment display chip, common cathode up there in the corner. I connect it to my A segment, and I also connect it to my B segment, like so. So I only built this circuit once, and already I've connected it to 2 of my segments. I've done the same exact thing for my C and F segment, my D and E segment, and then my G segment, I used NAND logic. Remember, one of your circuits must incorporate NAND or NOR logic. NOR substitution, NAND substitution. That's all that's going on here. So the steps, to reiterate and bring this full circle. Step 1, make your truth table. It's not necessarily the hardest part, but it's the part you must get right. You have 3 inputs, each relating to a different digit. And then you've got 7 outputs because you have 7 segments that you must turn on or off to make various numbers. Now, a quick note, you see these X's in my date of birth truth table. Those X's are don't care conditions. The number 7, I'm going to do something strange here and open up Paint, but the number 7 can be drawn with a 7-segment display like this, or it can be drawn like this. This segment right here is a don't care condition. That means that I don't care if it's on or off. So that is segment F. So if I look back at my table, to make the number 7, right here on row 9, segment F, I do not care if it's on or off. If it helps me in my K-maps, then I'm going to make sure it's on. You'll see that here in my K-maps, it did help me. The 1 denotes a don't care condition, making segments C and F the same. Now I have to actually find where that is because I didn't set this up correctly. Give me one moment. 2, 3, 4. Looks like it's this one right here. Let me double check. Yep, at 100. This number 1 should look like this. That's why you can't see it, because these are in the way. There you go, you can kind of see it there. So this number 1 right here is a don't care. It was originally an X, which you can see right here. And because it was an X, that means it could be a 1 or a 0. It being a 1 made my circuit simplify better. It made it simplify much neater, and it ended up matching my C segment, so it ends up saving me some work. But you make your truth table. You figure out what your 7 outputs are, then you make your K-maps. You should have 7 K-maps. Find out which K-maps are exactly the same. Like my A and B one, they're the exact same. You can see that here if I scroll in or zoom in. Because they are the exact same, I only build the logic once. Give me a second to get back to my Word document here. There we go. I only build the segment once in multisim right here. So you truth table, you K-map, you simplify, you build the circuit. And that is your goal with the date of birth project. Again, you have access to this date of birth document and this Excel sheet. And I think even if I look on Classroom, you probably, you even have access to my date of birth circuit. I've provided all of that for you. I'm going to provide this video in the same spot, in this date of birth example, Mr. Token, it's his date of birth, and I'll probably post it up here at the top or something. But you have to start somewhere. You have to go for it and see what happens. If you just say you don't know where to start, I'm going to say make your truth table. Try it, see what happens. And of course, if you have questions, don't hesitate to email me. I hope y'all being safe and well, and I'll provide you updates when I can on when we'll maybe start getting new information. That's all for now. Until next time.